laws of logarithm and how to apply them. Without wasting time, get ready with your writing material. Let's dive in. The first identity we are going to look at is the log of the base. The log of the base is equals to 1. That is, log A base A is equals to 1. Take down the following example. Example A, log 2 base 2 is equals to 1. Example B, log 3 base 3 is equals to 1. Example C, log 10 base 10 is equals to what? 1. Now the second identity says the log of 1 is equals to 0. The log of 1 is equals to 0. The log of 1 is equals to 0. You will take down some example on this identity. Example A. Log 1 base 2 is equals to 0. Example B. Log 1 base 3 is equals to 0. Example 4. Log 1 base 10 is equals to what? 0. The log of 1 is equals to 0 no matter the base. This identity is crucial, and you need to know them very well and to commit them to your memory. Now we are going to take a look at the next the next law. That is the law that guides us on how to multiply two log of the same base. You see, to multiply two log of the same base, take their sum. And to sum two log of the same base, take their product. That is, if you are multiplying two log of the same base, you take their sum, you add them. And if you are adding two log of the same base, you multiply them. That is what this law is saying. It guides us on how to multiply logarithm of the same base and how to add logarithm of the same base. Now take down example on this law. Example A. Simplify log 2 plus log 7, all in base 3. To add logarithm of the same base, multiply the log. So we are going to multiply the log here, which is 2 times 7, which is 14, base 3. And that is the answer to that. Now we are going to take example B, another example on this law. Log 2 plus log 3 plus log 4, all in base 10. The same thing, what we need to do here is to multiply the log. 2 times 3 times 4, all in base 10. And that will give us log 24 in base 10. To multiply log, add them. To add log, multiply them, provided they are on the same base. Now we are going to take more examples on the multiplication law. Multiplication or addition law. It teaches us how to multiply and it guides us on how to add. Example C. Log x raised to the power 2 plus log y, all base 5, all in base 5. What we need to do here, because since they are in the same base, we multiply the two. That's log s squared times y in base 5. And that will just give you log x raised to the power 2 y all in base 5. Yes. Example D. Log 4y raised to the power 3 plus log 5y raised to the power 4 all in base 10. What we need to do here is this question contains figure and contain alphabet. If the number will multiply the number, y and the alphabet to multiply the alphabet. So it's going to be 4 times 5, which is 20, and y raised to the power 3 times y raised to the power 4, which is y raised to the power 7, because it has to be the law of indices. So it becomes log 20 y raised to the power 7 base 10. Now, we're going to take the next law, which is called the quotient law. The quotient law tells us how to divide logarithm, and it guides us on how to subtract logarithm of the same base. This law says that to subtract logarithm and to divide logarithm of the same base, take their difference. Example 1. Log 8 divided by 4 all in base 2. What we need to do here is to take the difference. It's going to be log 8 minus log 4 all in base 2. Log 8 minus log 4 all in base 2. Then that is log 2 base 2 into 3 raised to the power 3 minus log 2 into raised to the power 2. Log of the base is equals to 1. So log 2 base 2 is equals to 1. Log 2 base 2 is equals to 1. So you now have 3 minus 2, because log 2 base 2 is 1. Log 2 base 2 is 1. And 3 minus 2 will give you what? 1. We are going to take another example, which is example B, which is log 1 over 8 plus log 1 over 9 all in base 3. Yes, log 1 over 8 is the same thing as log 1 minus 8. And log 1 over 9 is the same thing as log 1 minus log 9. Since though they are in different bases. That is to say, log 1 minus log 8 plus log 1 minus log 9 and base 3. Do not forget that the log of 1 is equal to what? 0. So it automatically becomes log 8 base 2 plus log 9 base 3. And log 8 base 2 is same as log 2 raised to the power 3 base 2 plus log 3 raised to the power 3 raised to the power 2 base 3. And this automatically become minus 3 log 2 raised to 3 base, because minus 3 log 2 raised to 2 base 2 plus log minus 2 3 base 3. Log of the base is equals to 1. Log 2 base 2 is equals to 1, and log 3 base 3 is equals to 1. So automatically what we have there is equals to minus 3 plus into minus 2 and plus plus minus is minus. So we have now minus 3 minus 2. And minus 3 minus 2 will give us what? Minus 5. Minus 3 minus 2 will give us minus what? 5. Any question? Let's fire on. Okay? We are going to take a look at another question, that is question C. The question says log 3 log 32 divided by 8 all in base 2. The same thing, when we want to divide two log of the same base, you take their difference. That is to say, log 32 minus log 8 all in base 2. Log 32 minus log 8 all in base 2. So log 32 is same thing as log 2 raised to power 5 base 2 minus log 2 raised to power 3 all in base 2, which is equals to log 2 raised to power 5 minus log 2 raised to power 3 all in base 2. That is equals to 5 log 2 base 2 minus 3 log 2 base 2, which is 5 minus 2. 5 minus 3, which is equals to what? 2. Look, alternative way of doing this is to divide 32 by 8. So 32 over 8, 32 by 8 give you 4. And 4 is the same as what? 2. That is log 4 base 2 is same as log 2 base 2. Log 2 raised to power 2 base 2, which is as 2 log 2 base 2, which is equals to what? 2. Now, we are going to give you some questions to text yourself. You cannot continue to tutor you without trying to see whether you are getting what we are passing to you. To do mathematics, to know mathematics is to do mathematics. Example 1. Evaluate log 25 over 5 base 5. 2. Log 1000 over 10 base 10. 3. Log 27 over 9 base 3. And 4. Log 64 over 16 base 4. Now you must ensure you solve this problem so that you will be able to assess yourself whether you are getting the message you are passing through. And we are going to provide a solution to this question so that by the time you solve and you did not get them, you know that something is wrong somewhere, and so you attempt them again. And if after you attempt them several times and you can't get them, then reach out to us in our comment section, and we will get to and give you the information or the solution as soon as possible. Further examples. We're going to take further examples. Anytime you you solve any of those assignments and you can't solve them well, that means you need to go back to react those laws. There is nothing that they will set in logarithm that is not in that found in those laws that are already been given to you. This question says evaluate log 1 over b. That is the same thing as log 1 minus log b. And do not forget, log 1 is equals to 0. So it becomes 0 minus log b. It becomes 0 minus log b. And 0 minus log b is equals to what? Minus log b. And that is the answer. We are going to take another question like this, that is similar like this, and that is know that the log of 1 is equals to what? 0. The log of 1 is equals to 0 no matter the base. And that is why we have log 1 minus log b to be 0 minus log b. Second example, evaluate log 1 over 2 base a. The same thing, this is the same thing as log 1 minus log 2. Log 1 is equals to what? 0. Log 1 minus log 2. And log 1 is equals to what? 0. So automatically you have 0 minus log 2 base a. 0 minus log 2 base a. And that is equals to minus log 2 base a. And that is the answer. Minus log 2 base a. We are giving you so many examples so that you get acquainted and how to apply this law. Now we are going to the next law of logarithm. This one is called the quotient law. This law tells us how to divide. No. That's a mix-up. This is another example. It says simplify. Sorry for that mix-up. Simplify log 8 over log 1 over 4. It's the same thing as log 8. Log 8 is equals to log 2 raised to power 3, which is equals to what? 3. And log 1 over 4 is same thing as log 2 raised to power with log 2 raised to power minus 2 base 2. Log 2 raised to power minus 2 base 2. Automatically, that is equal to what? 2. Now, the numerator is 3, while the denominator is what? Minus 2. Now, it becomes 3 over minus 2. And 3 over minus 2 is minus 1.5. Minus 1.5. Let's fire on. Now, this is the 5th law. This law is known as the power law. It says log m raised to power n is equal to n log m. Log m raised to power n base A is equal to n log m. Yes. We are still going to take example on this law to see how it is applied. Log m exponent n is written as log is n log m. The first example, log 8 raised to the power 2 base 2 is written as 2 log 8 base 2. So that's 2 log 8 base 2. And 2 log 8 base 2 is the same thing as 2 log 2 raised to the power 3 base 2. 2 log 2 raised to the power 3 base 2. That means 2 times 3 log 2 base 2. And log 2 base 2 is equals to 1. So it becomes 2 times 3 times 1, which is equals to what? 6. Alternative way of doing this is to take the square of 8, the square of 8, which is what? 64. So it will become log 64 over what? Base 2. So the alternative way is to take the square of what? 8, and it will now become log 64 base 2. Log 64 base 2. And log 64 base 2 is the same as log 2 raised to the power 6 base 2. Log 2 raised to the power 6 base 2, which automatically become 6 log 2 base 2, which is equal to what? 6. Since log of the base is equal to 1, so it becomes what? 6. That is the answer. That's the alternative way of doing that question, of solving that question. So we proceed. Then another example. This is log 100 raised to the power 4 base 10. This is example of the logarithm law of power, the logarithm law of exponents. Is written as 4 log 100 base 10. 100 base 10 is written as 10 raised to the power 2 base 10. So it becomes 4 into log 10 raised to the power 2, which is equal to 2 times 4 log 10 base 10. And log 10 base 10 is equals to 1. So automatically it becomes 8 times 1, which is equals to what? 8. Alternative way of doing this is to expand 100 raised to the power 4. That's an alternative way of doing it. And we see arrive at what? 8. Now let's try it. Let's try it. So you will now have log 100 million base what? 10. Log 100 million base 10, because you now have 100 raised to the power what? 4, which is log 100 million base 10, and which automatically give you log raised to the power 8 base 10. That is 100 million. Log 100 million is 10, which will give you 8. Or log 10 raised to the power what? 8 base 10, which is equals to what? 8. Note that 100 raised to the power 4 is the same thing as 100 times 100 times 100 times 100 into 4 places, and that will give you 100 million. Any question? Are you flowing? Let's proceed. Now we are going to take another example. This example is also from the law of exponents. Trying to explain more about the law of exponent. This law says 1/2 log b is the same thing as log b raised to the power 1/2. Yes, that is this law is derived from the law of exponent. This is not the law anyway. It's a derivative of the law of the word exponents. 1/2 log b is same thing as log b raised to the power 1/2. Examples. I'll simplify 1. Log of 16, log of the square root of 16. The log of the square root of 16, the square root of 16 is equals to 4. And now become log 4 base 2. And log 4 base 2 is same thing as log 2 raised to the power 2 base 2, which is equals to 2 log 2 base 2. And 2 log 2 base 2 is same as log 2 times 1, which is equals to what? 2. Which is equals to what? 2. Then example 2 in this series is a log of the square root of 25 base 5. The square root of 25 is 5. So it automatically become log of 5 base 5. Log of the base is equals to 1. So log of 5 base 5 is equals to, log 5 base 5 is equals to what? 1. Can we proceed? Any question? Let's proceed in the absence of question. Then we are going to take a look at the last law. We are going to look at the last property. This property will enable you to change from any base to base 10. This is the formula for changing the base of any logarithm to base 10. It says log m base a is equals to log m base k over log a base k, where a is the original base, then k is the new base, m is what? The number. That is log m base a is equals to log m base k over log a base k. That is a is the original base, k is the new base, and m is the number. This formula guides us on how to change logarithms from any base to base 10. We are going to take example of how to apply this law. Now, simplify base 10. We are changing to base 10 now from another base. Simplify in base 10. For what we saw in that formula, log 81 base 3, to change it to base 10 is going to be log 81 base 10 over log 3 base 10. Yes. Just take the logarithm of the number over the logarithm of the base and apply the new base. Log 81 base 10 over log 3 base 10. Yes. This is the same thing as log 81 base 10 minus log 3 base 10. Log of change of base. This is change of base formula. Same thing as log 10, 81. Yes. Log 81 is equals to 1.9085 from the logarithm table. And log 3 is equals to 0.4771, also from the log table. And what are you doing? We are going to divide 1.9085 divided by 0.4771, and that will give you what? 4. That will give you what? 4. On this note, we have come to the end of this tutorial. In our next tutorial, which is going to be out in a few days, is going to be the law of logarithm part 2. And in that series, we are going to use these laws to solve so many examination questions. In case you have any challenge in what you have just learned this evening, do not hesitate to reach out to us in our comment section. The name of our channel is Jordan Pickcroft Obi. And our phone number and also a WhatsApp number is 080-3554-2119. We are looking forward to seeing you in our next tutorial. Thank you and God bless you. Bye.